Notes. Here we go. 9 dash. What section is this?
6.
Sure.
7. 6. 6.
Okay, so it's about lines of symmetry and rotational symmetry. So I'm going to show you some things that are really kind of simple to do, but make sure that we pick up on the things that aren't that easy. Okay. So how many lines of symmetry does the figure have? What is a line of symmetry? It's where you can
Like cuts it perfectly in half.
Yeah, I mean you can fold over the other side on top of itself. Okay, so we'll just use a little ruler here. So on the first one, wow, that's right. That's 2. So there's 1 folded over on itself.
Is it 2?
There's 2.
Definitely 4.
That's perfect.
But you can go diagonal.
No.
Diagonal does not work.
Good. That makes
Diagonal.
sense.
Yeah.
That doesn't work because this
No.
goes up to there.
It's not that. It's not the worst.
Yeah, outline was a tricky trade.
Please shut up.
Definitely do the tree.
This one,
It's only 1.
there's 1,
2.
2,
Ooh. That's 5.
Are you
3.
Yeah, wow.
You can just.
Alright, what's
sure?
4.
Okay, what's going on?
You can actually point to the
He's
side.
telling
Five.
us where the lines of symmetry are.
Hey, shut up.
Yep.
Answer my questions. If you have a question, raise your hand. So, in an equilateral triangle or figure, in this case an equilateral pentagon, you have as many symmetrical lines as there are vertices. You can see if that's true for all the figures.
Wait.
So if we look at the vertical side like this, that'll flip over to the other side. So that is a line of symmetry. And if you go to each vertex and drop it down an altitude, you'll notice that they do flip over on itself. So how many are there?
5.
5. Okay, now C is not an equilateral figure or a regular figure, but it does have a line of symmetry. 1. Got it?
Yeah.
Sound pretty cool?
Easy.
Those are lines of symmetry. Alright, so let's just talk about rotational symmetry. Start at the top here. Does the figure have rotational symmetry? If so, describe any rotations that map the figure onto itself. Description means how many degrees. So how do we figure that out? So if we look at this, a point of symmetry is what it's rotating around. So if we look at lines of symmetry, and in a square, we have quite a few lines of symmetry, don't we? Usually the lines of symmetry come to a point at the point of symmetry. So the question is, if I move this to there, do I get the same figure?
What do you mean?
Yeah.
No.
No.
If you move
Oh,
one
you mean
to
the
where?
line or the actual square?
The whole
I move the square,
Oh.
and this is my next question. How many degrees is that? 45.
45.
So if I only move this 45 degrees, do I get the same figure? It's the same figure, but does it look exactly the same as it does here? No, it's tilted, right?
You did move down.
So be careful that you don't confuse the lines of symmetry with rotational symmetry. My question then is, how much does it need to rotate for it to be exactly the same? 90. So here's the key. It's 180 degrees or less. If you have to do more than 180 degrees, then it is not rotational symmetry. So obviously, if you can do 180, then you consider it rotational symmetry. And anything less than that. So this has 90 and 180. Got it?
Yep.
So don't confuse lines of symmetry with rotational symmetry. Those lines of symmetry can help you identify where your point of rotation is. Regular hexagon, here we have a regular figure.
So it means less than
non-symmetry as its vertices.
So 6.
Yeah, so here, there's a line of symmetry, there's a line of symmetry,
No.
Yeah, it's 12.
there's a line of symmetry, alright? Straight down each one. How many lines of symmetry are there?
12.
No.
1, 2, 3, 4, 5, 6 lines of symmetry.
Oh, it was.
How many vertices are there?
Six.
What did I say about regular figures?
They have the amount
Yes.
of vertices.
Thank you.
Get it.
So far, we have a pentagon and we have a hexagon. I wonder if it works for all the other ones.
Maybe.
Alright, now that's just lines of symmetry. Rotational symmetry. If I only moved this to there, that corner to there, that means the corner would be up here. So that obviously doesn't match. But if I moved it to the next one, this corner goes to that corner, and we have the exact same figure, right? So I can move that corner to that one to that one, and I'm back. There's my 180. How many times did I rotate it? There's 1,
60.
2, 3. How many degrees is that?
180.
Yeah.
Yeah, it's 180 degrees total.
Yeah.
But how many degrees is this one right here?
60.
So you can kind of look at the degree there. Yeah, that's going to be 60.
So on the homework, do you want us to like draw the line of symmetry and then do this with every problem?
You do what it tells you to do. 60,
Okay,
120,
I will do
and 180. Those are the 3 degrees that you would list for rotational symmetry. Got it?
Wait, what about? Oh.
So you got to, even though 60 goes into 120 and 180, you still got to tell me all of those. All right, and then the kite line of symmetry. Kite has a line of symmetry.
Yep.
But does it have rotational symmetry?
No.
You have to go through
Yes.
six.
No.
If I rotate it 180 degrees,
No.
you don't get the same figure, or the same direction of the figure. You have to go 360 degrees to get the same thing, which that doesn't count as rotational symmetry.
Yep.
Got it? Alright, so that's kind of what this was describing down here. Identify, let me see this here. Okay, we can do this. Identify the line of symmetry. Let's put this up here. Identify the line of symmetry. Who thinks they know what that is? So I'm going to set this up here and we're going to have you guys come to the board. Oh, that's right.
Yeah, I was gonna.
Never mind, it's
Okay,
right
do
here.
it.
Here are your 2 lines of symmetry on that one.
See?
Any questions on where the lines of symmetry are? Alright, and then the rotational symmetry right at the bottom, it shows you it's 180 degrees. You'll get rotational symmetry, but not less than 180. 90 makes it look like a bow tie, so it has to be 180, but it does have rotational symmetry because it's 180 degrees or less. Alright, now, last part of this. Let's just see if you guys can do this. Don't say anything. So, who wants to come up and do number
Me.
1?
Well, no, I don't.
Nate, do the first one. Nick, do the second one.
Shut up, 18.
Or you can use this if you want. Doesn't matter. Yeah, when you're done, sit down, and then we'll ridicule you and make fun of you.
Oh, I didn't think.
You're off with the blue. Yeah, but you're good.
Yeah.
Hey guys, sit down.
Oh, it erases it.
That's good enough. Okay, are you done? Okay, sit down.
Nice, Nick.
Thank you.
Okay, so the trapezoid here, you're all assuming that it's a isosceles trapezoid, which typically in geometry we don't assume that, but this is just, we're just looking at the figures, it's okay to assume it here. So yeah, this has a line of symmetry, 1 line of symmetry, this has 4, right?
Yep.
Any other questions?
No.
Alright, good, good.
Yep.
That makes me happy. You guys are so brilliant.
Thank you.
Who wants to do number 3?
I kinda do.
Come up, Garrett,
That's a cool one.
you want to do number 4?
Yeah.
You don't have to use the ruler if you don't want to. Just use the blue marker, please.
Thanks.
Okay, go ahead and do it. Don't say anything until they're done, or actually until they sit down. When you think you're done, you sit down. Now here, I'm asking for lines of symmetry here. I know that it says rotational symmetry up there. We'll do rotational symmetry in a second.
Oh,
God.
Okay,
the diagonal one's wrong.
this is good. There's only one line of symmetry here.
I was close. Is it the diagonal ones that are messed up?
These are right.
Oh, really?
That's right. This folds up on that.
Oh, sweet.
It's done right. Lines of symmetry are correct here. Alright, now,
Hey, well.
rotational symmetry. If I only go to here, that just puts this right there.
True.
What do I have to do?
90.
Ooh.
Yeah, this has to go all the way to this point. That is 90 degrees.
Ooh, that was really
That's an easy way of looking at it, how you do it. But your line of symmetry, that's your point of rotation. Here, rotational symmetry or not.
No.
No, you have to go all the way around to get back up there. Okay? Alright, so no rotational symmetry on 4. 90 degree and 180. You have to list them all. 90 and 180 on number 3.
Them are easy. Oh, can I do this one
Alright,
too?
so this one, I want both. So we'll put this in the center. I want someone to do line of symmetry, some different people. Who wants to draw the lines of symmetry first?
Right.
Somebody who's not been up here.
Okay. Someone.
Line of symmetry.
Oh, wow.
There's 1,
That's harsh. That really hurt.
2, 3, 4, 5, 6, 7, 8. 8 lines of symmetry. That's true?
Yeah.
Point of rotation pretty much right in the center. We're assuming this is all the segments and everything are equal.
40.
There's 1, 2, 3, 4 to get back to 180 degrees. What's 180 divided by 4?
30. 40.
45 degree rotation, 90 degree rotation, 135 degree rotation, 180 degree rotation. You have to give me all of them.
I was thinking 120.
Okay, did you hear what I just said?
Yes, sir.
All of them. Okay, otherwise you don't get full credit. Alright, good job.
Thanks.
This one's easy.
Oh, that's great. We got that on camera.
This one's easy.